come for the bad puns? Stay for editing the ZFS source code in order to recover data from a very badly damaged ZFS pool. Coming up after the bump. So first off, I want to say very special thanks to Gilware. They were our data recovery partner. This is our data recovery ID. So if you need to recover any data, use this ID, and that will let them know that we referred you to them. That will be really good. So Gilware is a data recovery lab. They're really good at recovering physical hard drives after very terrible things happened. This was just sort of a small, like, work NAS, not really anything. It's not like, you know, we can afford racks and racks of drives with, you know, Insanity and blah, blah. So this was actually just a really simple 3-drive RAID Z1 setup, and you may have heard us talking about it before, but the pool basically became corrupt when we had multiple hard drive failures. Now, one of the hard drive failures was catastrophically bad. It was so bad that the information was basically unrecoverable. A second drive developed physical problems almost immediately thereafter, and the second drive with physical problems was still a little bit readable, but it still had problems, and so we ended up sending the array off to Gilware to help us do the physical recovery. Now, they were able to basically get us back to where we needed to be with 2 of the 3 drives, but it was a 3-drive RAID Z pool. You could really only lose 1 drive. However, one of the 2 remaining drives still had some corruption and still had some problems, and so their data engineers worked on the problem, and we worked on the problem ourselves. And you know, their engineers are competent. They're aware of ZFS. They know what they're doing as far as programming goes and data recovery and the tools that they have to recover that. And so, having sort of the computer science development background that I do, I was like, well, I can dive in. I can do this. I can run this programs and it's fine. So I'd never really had to do anything like that before with ZFS. And as a result, we, you know, dumped a whole bunch of time into doing computer sciencey things, like file system engineering things, to try to understand the situation with ZFS and try to recover the ZFS pool, and we were basically able to do it. The problems with the pool really stemmed from corruption in the transaction log, corruption in the metadata that store, like the file organization and some other parameters with how the files work. And a lot of the stuff that you see here is sort of the aftermath of that, and so I'm sort of going back and trying to document the commands that I used and remember everything and sort of put it together. So we're going to dive in and let's take a look. So this is probably what you came here for, right? This is the actual, like, nitty-gritty. We're going to edit the source code and everything's going to be insane. Well, bad news. Learning to program and learning to do that stuff really does not translate well into a YouTube video. So you're just going to have to settle for the aftermath. We use Debian and ZFS for ZFS on Linux for the recovery because I'm more comfortable with the Linux development environment, more comfortable than on FreeBSD, and ZFS on Linux is basically the same code base at this point. And so Debian has a really cool set of commands where you can just basically tell it to go and get the source code for particular packages. And so that's what we've done here. We've gotten the source for the Linux kernel, just in case we need to edit the ZFS driver. We've gotten the source code for the ZFS utilities and other ZFS related packages. The particular way that we settled on recovering this was actually with ZDB, which is part of the ZFS utils package. Now, the first couple iterations of this, I was sort of doing this the Debian way and then sort of building my own debs and then dpkg and -i installing those, but it ended up being the case that we needed to modify ZDB so much. I was doing that a lot, and then so it basically came to a point where I was like, I'm just going to build the kernel modules and kernel stuff myself. I'm not going to bother with doing it the Debian way, because when you're doing this, you can actually take the code and compile it and convert it into Debian packages, and then you can just dpkg and install them. Of course, you've got the source code, you can just compile it and, you know, just copy the binaries around willy-nilly, which is what I ended up doing. Be careful, your mileage may vary. We're going to take a look at the ZFS util. Okay, so ZDB is basically the ZFS debugger that will let you get at the raw ZFS part of the file system, which is what we ended up doing. When we did that, there were all sorts of interesting things in here, just looking through the source code about, you know, abort if the space maps are not correct, abort for this reason, abort for that reason, and that sort of thing. When we encountered those problems, we basically looked at the source code and said, well, we probably don't need that. Let's take that out. And think of it like replacing fuses. It's like, oh, this is a 20 amp circuit and it keeps blowing the fuse. Let's put a 30 amp circuit in and see what blows up. Let's put a 40 amp circuit in and see what blows up. So there's actually a lot of stuff in ZDB that cause it to basically crash if anything is slightly weird. And so most of this involved sort of taking it apart and making it so that it wouldn't crash, or making it so that it would continue, or making it print extra information so we could examine the situation and sort of see what was really up. So this is the situation. We've got our disks that we used, DD Rescue and Test Disk, and these are not our only copy, so if we screw up, you know, nothing of value was lost, theoretically. The ZFS file system is on there, but we can't access certain paths. Now, in my case, I always want to mount it read-only so that it doesn't continue to mess things up. The ZFS file system has a transaction log, and it's continually writing to the transaction log, and sort of the more messed up stuff is, it just sort of keeps writing. When something weird happens, when an inconsistency happens, I wish that there was an option to tell ZFS to, when any inconsistency is encountered that is unrecoverable, to put the file system into read-only mode. I see why that's not an option, because ZFS is designed, that's what it's not a default option necessarily, because ZFS is designed for racks and racks and racks of disks, and you would never, you know, you would never necessarily want to take the entire pool offline just because there's one uncorrectable inconsistency. But for small installations, where small is, say, less than 10 hard drives, it would be nice if it would go into read-only mode, because I think that greatly increases the chances that you'll be able to recover. I think that in those situations, when you encounter hardware that has died that way, it is more likely to be a bug, at least if working with ZDB is really any indication, because space maps and some of the other problems that we encountered, I think we're really just down to bugs or very slight inconsistencies in the pool. Most of the time online, when somebody encounters a situation like this, they'll say, oh, it's probably just a little corruption in your pool. Make another pool and then copy all the stuff out of that pool, the corrupt pool, into the new pool, and everything will be fine. Everybody does that, and it seems to be not really a big deal. In this situation, it's a little more severe. So I'm a little bit green at this, and so I don't really have a full and complete opinion yet, but I'm just going to show you what I did, and you can judge for yourself. So we'll see what happens. Alright, so at this point, the pool name is V1, and then the thing that we're looking for under that is called ZDataset1, just because I don't know why. And, well, I mean, I do know why, but it is what it is. At this point, the file system is not mounted. GDB can operate on non-mounted ZFS file systems, which is handy. Although sometimes you will have to mount the file system in read-only mode because you want to set the ZFS pointers to point to a specific transaction log entry in the past. You can use ZDB to actually tell you a list of available transaction IDs, and you can roll back. Normally, ZFS does not let you roll back to way in the past, because way in the past may have file system organization and pointers to blocks that are no longer there, that have been freed. Sometimes it can be a lifesaver though, and there's an undocumented -t command that will let you actually do that. I've run a few commands, and we're just going to sort of jump right in because this is way too tedious and weird. There is a thing that you can do, which is echo 0 into this ZFS parameter, SPA load verify metadata. You really want to do that, because if you don't, it's going to verify space maps and a whole bunch of other things. It's going to crash sort of unnecessarily. So if you do that, then you can actually mount the system. In my case, the file system was mountable, but some directories were unreadable, and I wanted to see if earlier points in that transaction log that I mentioned were actually readable. And so with ZDB, you can actually see the full transaction log history of the pool. And so we're going to do that real quick with ZDB-E V1, because V1 is the name of the pool. And then we're going to grep for the transaction log. That's actually going to crash pretty quickly, but it's basically saying, oh, I can see create transaction 4, which is really a long time ago, and not really all that useful particularly. We can see that, oh, there is dataset 1, and this is the transaction log that goes with it. And so we can probably mount that, assuming that ZDB does not crash. Now, in an ideal world, ZDB does not actually crash. It might have left a core here. Yeah, so, well, it didn't actually leave a core. That's the old one. We're going to look at that in a second with GDB. But basically, ZDB is crashing here. So it's like, no, why is it crashing? This is not good. I saved the output of ZDB scan. You can also use ZDB to scan for files, and I saved the output in this. So here are the space maps that I was telling you before, which basically tell you where the free space is, and then you have entries. This is like, ZDB is like a database, because ZFS is more like a file system really than a database. Here are MP3s and information about the MP3s and that sort of thing. So this is telling us what the object is, and so we can request more information about that particular object ID once we've actually gotten to the point where the file system is mountable. Now, to actually mount it, you want to use a command like this. This is zpool import -o read only on. Read only on when things are this damaged is super important. You really, because ZFS will be constantly updating the transaction log, and you don't want to create a fork in the transaction log. So if you roll back the transaction log a little bit, and that's not actually the one that you want, it'll start updating again, and you don't necessarily want that if there was more stuff in the transaction log beyond the one that you're starting from. Normally, ZFS will not import something with a really old transaction log. It'll actually give you a list of about 30, which represents about a 5-minute time window, which is why if there's a problem with the file system and something weird happens, you will need to sort of deal with it pretty much immediately for the transaction log part of it to really be of any use. So in this case, we sort of defined a transaction log ID, and we're using the undocumented -t switch to actually mount that. Now there's some other, there are various commands of other switches that basically force it, yes, force, yes. I'm really sure that I'm going to accidentally destroy everything. So you really should be careful. This video is a very poor substitute for actually reading the documentation and the man pages, and just don't dive right in unless you're operating on a copy of this or you're just doing it for sort of experimental reasons. It took a lot of trial and error, many hours of trial and error, and sort of poking around. I mean, you can sort of see just some trying different transaction log IDs and going through the source code and saying, I wonder why this actually failed, and I don't really understand what happened here. The ZFS module in the kernel actually crashed. There was a lot of really squirrely stuff going on. You're just getting the overview. And so it's a little patchy at best. So in this case, we're looking at the ZDB log, and we see the object ID, and some of these object IDs are inaccessible because the folders that contain them have been damaged. And so when we were trying to actually, I don't know if this is actually mounted right now. Yeah, no, it's not mounted right now, but like the MP3 folder was completely inaccessible at input-output errors. But the files within it were accessible to ZDB because ZDB is just the database. It's not really the hierarchical component of it. So if something farther up the chain is damaged, but stuff inside there is still something that we can get at. And so that was true of the album, and that was true a lot of the recent work files that Logan was sort of dealing with. And so in this case, this is a dump of all of the files on the entire file system and all of the information about them. So we created a shell script, which is extract ZFS file. Basically, this ZFS extract file will extract the information about the file because the files are stored in blocks, remember, and it can only pull out one block at a time because this is a database program. It doesn't really know about files. So it'll pull out one block at a time and then sew the files back together. So if we look at our ZDB log text file, which is not really the ZDB log, it's just the stuff that's in here, there is a file ID that I identified before when I was having to go through all this and look, find the missing file. Hopefully I can find it. Hopefully it'll search through this file pretty quick. It's like 600 megs. So this was basically a file of interest, and we're looking at it here, and we can see that it's in object 645930, which is the ZFS directory. This is the information. This is the path for the directory. This is the WAV file that we're interested in, and so it's listed here as an entry in this particular directory. But we actually want to find the next entry, which is here, and it shows us the object ID. So this is saying object level 3, you know, the data size is 19.8 meg, ZFS plain file. There's some meta information about it. We actually want to extract that. And so what we're going to do is ZFS file and then paste in that ID for the shell script that we wrote to recover those files. Oh, and then the directory we want to put it in, which I'm going to put it in the extracted folder. Oh, you got to give it a file name. So for every output that it put here for that, it actually extracted a chunk of data from the file and then put it back together. So if we go into the AAA or extracted folder, we can see that, you know, this begins with RIFF WAV. This is actually a WAV file. It has actually reassembled the file. If you want to see sort of a more textual version of that, okay, I finally got the command for that. So we would want to run ZDB-AAAA DDDD whatever on our data set and then the file ID. And so what this is doing, this is printing out the actual list of blocks that are associated with this file. Now, there's actually multiple levels of blocks, and some of these are actual information about related to the file and that kind of thing. In our case, all we're really interested in are these level 0 blocks. And this is telling us information about where they are, how they're stored, and then this is telling us that, you know, we've got a total size of 19.8 megabytes. ZDB will extract these blocks one at a time. ZDB doesn't seem to have a command, at least that I could figure out or find, or that I understood from looking at the source code, that would extract all of the stuff for these blocks and put the file back together. So that's why we had to create the extract ZFS file shell script. And so this is actually, well, it's not just really shell script, it's Perl, but yeah, close enough. We'll pretend. Don't tell anybody about our happy little Perl script. It'll be just a secret between us. Little Bob Ross on you, I guess, there. So this extracts the blocks from the file and puts it all together. Now, in our case, it was so damaged that ZFS was crashing when we were telling it to go and do these things and try to extract this and that sort of thing. Debugging those crashes, there's a tool called GDB. So we would do gdb./ZDB, because this is our specially compiled version of ZDB, and then core, because when you see something that's like something crashed, core dumped, or sometimes the kernel crashes and you get a core dump, you'll have a core file that you can work with to debug why it crashed, and GDB will help you do that. And so in this case, we ran that, and this is showing us that, you know, ZDB-DDDE-V1, which is just going to generate some debugging information output, was what actually crashed and generated this core file. And so this was this is not actually the correct version of ZDB, so this output is not particularly useful, but a command like that can be used, and covering GDB is maybe something that we do in a future video, but the GDB command will help you figure out where the program is crashing so that you can then go examine the situation in the source code. Now, sometimes you're not going to be lucky. You can't just, you know, change the condition, or you can't just change the thing to say, oh yeah, I don't want you to crash anymore, because then you have to do something with it. And so you can't just change the program. You have to actually figure out why it's crashing and understand why it's crashing, and then make the appropriate modifications to the program. Most of the time when the program is crashing, it's because of bad data, and that makes sense in this case because we've got damaged, destroyed hard drives. So you really have to look at the damaged data and then figure out if there is a way to work around the damaged data. There may not be. And so in the case of one of the album tracks, the mountain track that we were looking for, I've got the WAV file for it, but the original data file that went with it was basically unrecoverable. There doesn't seem to be a page entry, a complete page entry for it in the database. There's a pointer for it, but the pointer for it points to one of the blocks that was unreadable on this particular hard drive. And because we don't have the other hard drive, we don't have the other information with which to recover that. And so this is pretty cool though, because we've only got 2/3 of our mechanical disks, and there's still enough working ZFS infrastructure at the lower levels that is basically able to fill in the missing pieces and basically give us an entire file. Even if parts of the directory are inaccessible, some of the files are accessible, and you can get at some of the files. It would be nice if there were more advanced recovery utilities to be able to do these kinds of things, but by basically producing a list of all of the readable files with ZDB and then manually extracting all of the ones that were really important, we were basically able to get back 99.9% of all of the stuff that we really needed. And that's the 0.1% is probably down to the parts of the disk that were physically unreadable on the second disk that had problems. So this was a ZFS 3 drive situation. One drive exploded spectacularly, and the other drive developed mechanical problems not very long thereafter. And we ended up getting almost the entire second drive back, but there were quite a few bad sectors, and there were quite a few completely unreadable sectors. And so when you've got a 2-drive failure situation with ZFS, that's really, really bad news. And this is only 3 drives. So everybody should be running RAID Z2, right? Yeah, you're going to run RAID Z2? Yeah, that would be good. So once again, thanks to Gilware, our data recovery partner. Even the hard drive burnisher just couldn't save us on this one. But we were able to get everything back though, so I think this is still a net win. I mean, it was a little harrowing, and it did take a couple of weeks to really get in there and recover the information once the drives had been restored to an operational state. But we were able to basically get everything back. This is huge. This is a really big deal, because it shows that ZFS's maturity and viability, even in the face of multiple drive failures, we were still able to basically get everything back. And it also shows that the development tools and the debugging tools are far enough along that at least somebody who knows what they're doing can basically get most of the information back. Now, ZDB and some of the other tools were a little bit buggy. I was surprised that we had to do as much as we did, and it did take a while. And I really sort of lament the fact that we had to put a Perl script together to extract the files one block at a time. I'm not sure if it's just lack of documentation or low reading comprehension on this side of the fence that there's not a utility to do that. I'm sort of surprised by that. But now at least we have a Perl script to do it, so that's good. And then we also extended the Perl script to extract entire directories, so we could specify a directory object, and it would sort of dive in and say, oh, there are all these files in the directory, and then it would do that. Unfortunately, we did not make it recursive, which would be a problem. But hey, throw it on GitHub and the next person can make it, make it recursive or whatever. It should be good, whatever. There are some bugs. The code's, it's really good, it's functional, it served our purpose, but maybe somebody else can work on that. So if you're in the unfortunate position of being in this situation and you need help, you're just going to have to head on over to the forums at forum.techsyndicate.com, and we'll try to help you there. I'm Wendell. This has been a ZFS Disaster Recovery Insanity Hair on Fire crazy whirlwind tour of insanity, and I'll see you in the forums. Signing out.